line of intersection of two planes. If the planes a1x plus b1y plus c1z plus d1 equal to 0 and a2x plus b2y plus c2z plus d2 equal to 0, if they are intersecting, then we'll get a line, because generally the representation of this is like this. So let's say if I have a plane, so this is a plane and there is another plane. So if there is another plane, then we'll have a line of intersection. Even let's say if I want to uh, take it more clearly, so this is xy plane. Let's say if this is x axis, this is y axis, this is xy plane, right? And then if I want xz plane, so xz plane is this. So all, I mean the entire area will be xz plane. This is, so we have a line, this line as a common line, right? So whenever two planes intersect, we'll get a line. So how do we find that line? So if I want to find the line, so the equation of line in 3D is, so x minus x1 by a1 is equal to y minus y1 by b1 z minus z1 by c1, where x1 y1 z1 is a point on the line, is a point on the line, and a1 b1 c1 are the drs of the line. So how do I find the drs of the line? So if I say these are drs of the line, so it belongs to this line, so it means the dot product, I mean the normal to the plane will be perpendicular to this, right? So the normal will be perpendicular to the plane, and here also the normal will be perpendicular to the plane. So a1 b1 c1 dot a1 b1 c1 is equal to 0 and a1 b1 c1, because this is with respect to one plane. Now we are looking at other plane. So because the line belongs to both the planes, right? So if the line belongs to both the planes, it means the dot product with the normal will be 0. So a vector is perpendicular to two vectors, that is the meaning of that. So a bar dot b bar equal to 0, a bar dot c bar equal to 0. So it means a bar is along, I mean this is along lambda into a1 b1 c1, the definition of vector product or the cross product. So if a vector is perpendicular to two vectors, then the cross product of the two vectors will be along the direction of that vector. So a1 b1 c1 is proportional to lambda into a1 b1 c1 cross a2 b2 c2. So this is what I mean, we'll get the drs. So now we got the dr. So now I want the point on the line x1 y1 z1. So if I want the point x1 y1 z1, so x1 y1 z1 lies on both the planes. So a1 into x1, b1 into y1, c1 into z1 is equal to d1, a2 into x1, b2 into y1 plus c2 into z1 is equal to d2. I mean plus d1 plus d2 is equal to 0. So I have two equations but three variables, no? So the variables are x1 y1 z1. So if I want to reduce it to two variables, we don't have any other equation, no, to solve the third variable. So what we do is, for solving these three variables, we'll make one variable 0, such that the other two lines should not be parallel. So either x1 equal to 0 or y1 equal to 0 or z1 equal to 0 we can make. So whatever we are making, then we are making sure that the two, whatever next two equations will get, no. So let's say if I make x1 equal to 0, b1y plus c1z plus c1z1 plus d1 equal to 0, b2y plus c2z plus c2z1 plus d2 equal to 0. So b1 by b2 is not equal to c1 by c2. If I make sure that condition, then this is fine. If they are equal, then you should not make x1 equal to 0, then make y1 equal to 0 or z1 equal to 0. So make sure that those two lines which will come after that will not be parallel to each other. So if I make x1 equal to 0, the lines will be b1y plus y1 plus c1 z1 plus d1 is equal to 0 and b2 y1 plus c2 z1 plus d2 is equal to 0. So now solving these two, I can find y1 z1, right? So y1 z1 1, So C1 D1 B1 C1 C2 D2 B2 C2. So y1 by that of C1, I mean that of C1 D1 C2 D2 is equal to Z1 by that of D1 B1 D2 B2 is equal to 1 by that of B1 C1 B2 C2. Now I got y1 Z1, so y1 is equal to this by this, Z1 is equal to this by this. So I got y1 Z1. So now I'll substitute everything here, then I'll get the line of intersection of both the planes.